Tonight we're going to be looking at briefly robot maintenance, and then we're going to spend a little bit more time on robot triage, which is what is like emergency repairs at events. So starting with some basic maintenance, these are kind of general, like every robot type of thing that teams should just be looking for, and that we should be looking for any of our pit crew kind of get trained in this. Metal shavings are one of the biggest things just because you end up working on the robot, you end up drilling things, working over it. Metal shavings also is wood shavings, dirt, anything else. Metal in particular is bad. It's just because it's conductive. So if it gets on certain circuit boards and things, it can cause things to short out. That's the worst thing where you start frying components. Most of that doesn't happen anymore. Most of our components are either sealed, conformal coated to where they don't allow like the metal shavings to chip or to short them out or anything. But it's still a problem. It still makes the robot dirty. Still causes issues. So we want to make sure that we're trying to anytime we're drilling on the robot, we have a drill cloth or some sort of towel or something else to catch the metal shavings. A lot of people, some teams just use a t-shirt, whatever you can get to put under it, do whatever you can to try to catch the shavings. A vacuum helps too. If we have an extra set of hands and somebody can have the vacuum hose right under where you're drilling and they can start sucking out all of the shavings or cutting or whatever else you're doing on top of the robot that's going to be generating debris. Whatever we can do to catch it is helpful. Sometimes we do end up having to just like literally tip the robot over and tip it in a way that allow the shavings to fall not into the robot. So if you're drilling somewhere up high on the robot, if you can lean the robot to its side or something, and so when you're drilling, the shavings end up going on the ground, so they're easy to pick up. That can help. And then every once in a while, just making sure to go around and actually vacuuming compressed air. Sometimes if they're in corners and can't get the vacuum into, just getting the shavings out of the robot. We don't want all that dirt and debris to stay in the robot whenever possible. Rollers and wheels, so all of our like intakes, launcher wheels, pretty much anything that's going to be contacting the game piece, we want to make sure we're keeping those very, very clean. A lot of times, especially on our intake rollers, if they have any sort of grippy material on them, like a latex or a silicone or anything like that, or like the compliant wheels or any of the TPU rollers, any sort of rubber, as they collect dust, they don't, the material properties stop adhering to the game piece as well. So we always want to clean them. We found that Simple Green works really well. It's a cleaner you can buy at like Walmart or anywhere. Microfiber cloths, spray some Simple Green, it works. Other teams swear by alcohol, anything like that that's just going to wipe away the dust and dirt that gets trapped on the rollers that doesn't cause it to not be sticky anymore. And so normally this is an every match type thing on our intakes. This is something that teams will do, and it gets you like a very consistent experience when you're going through and doing it. It gets the mechanism kind of working the same way every match. If you're not wiping it down, you'll end up eventually throughout the event having intake issues. You're not sure why it's not grabbing the ball anymore or the game piece, whatever it is. And a lot of times it's just because your rollers are dirty. Lubricant. So this is another thing that has to happen throughout the event. Some of the times you're building mechanisms that are going to be fully greased and they're going to be packed and they'll be enclosed and you don't have to really worry about re-greasing in the event. Kind of depends on how your team likes to do things. A lot of times for Spectrum, we'll use dry lubricant, so we're reapplying pretty regularly because there's not as much physical material and lubricant there. It's not like we're packing our gearboxes full of actual like grease or anything. We're basically spraying on a PTFE Teflon type coating that's going to actually stick and adhere to the gears, and it works pretty well, but it does need to be reapplied a little bit more often than some of the packed grease. But it has the advantage where it's easier if you have to touch it. It doesn't collect as much dirt either, so any of the dust and dirt and things don't get caught in it like it does in regular grease. So that's why we use it for almost everything on a robot. But we do want to be applying it regularly to make sure that all of the mechanisms are doing what they're supposed to, reducing friction. We're not getting a lot of gear wear. We're not rubbing any of our sprockets or gears or anything down to where they're going to wear down and then cause failures or just have a shorter lifespan. FRC luckily doesn't have, most of our things aren't running very long, right? A match is only 2 minutes and 30 seconds. Most robots aren't running that many matches in a season when you compare to like industrial equipment that's running, 24 hours a day. So we have a relatively okay time using less grease. If you run something for a little while without grease, it doesn't normally cause severe damage, but you definitely want to make sure things are getting greased and re-greased. And depending on the mechanism, we kind of figure out which parts of it and when need to be greased, and we'll kind of make a schedule for each robot, and the pit crew kind of knows, okay, these need to be re-greased, or you just go through with the spray can or the bottle of Tri-Lube, which we'll use on a lot of our smaller gearboxes like planetaries and things like that, and chain. They get done with Tri-Lube, and then the other ones we have like a spray bottle of either WD-40 PTFE spray or one of the other PTFE dry sprays, and they work pretty well. A lot of the rest of the mechanical maintenance is just kind of making sure the robot is in the state that it's supposed to be in, right? It's very easy for things to get dirty. So anything that's going to touch the game piece, anything that's going to slide or move in general, we want to make sure is clean. So any like elevator rails, we don't want them gathering a bunch of dirt and grease and grossness if we can avoid it. Wheels on our actual robot. So the drivetrain is a good place that a lot of people forget to check, but every single drivetrain I've seen in FRC collects carpet fibers in some way. Like we've pulled them apart from old robots where you're just pulling fibers off because they just like wrapped around the entire wheel shafts. And ideally, we want to be catching that stuff early, so it doesn't accumulate throughout multiple events at a time. So if we go through at like lunch is a good time. Anytime we have a decently long break at an event, you want to go through, look over every little nick and cranny of the robot you can, find places where there's stuff in the robot that's not supposed to be there, dirt, carpet, parts of other robots, like we've seen it all. Find it, get it out, get the robot back to the state it's supposed to be in, the way it's designed to be. And then the other thing we're doing at that same time, we're kind of looking for anything that's out of place. We're also looking to make sure all of our bolts and fasteners are actually tight. Some teams take this further, and some mechanisms require it a little bit more than others, but most of the time we're going to always use lock nuts whenever possible so they don't vibrate loose too quickly. We're also going to use Loctite on nuts where if we can't use a lock nut, we're going to try to use Loctite. So we're going to try to make sure our fasteners don't vibrate loose too easily. For very critical bolts, we'll go through and we'll completely reapply and retighten when we need to. There's other teams, we haven't done this on Spectrum, but it's something we might do depending on the mechanism or use case, is you can take a paint pen or nail polish or anything and draw a line on the bolt so you can start seeing if it's been loosened or tightened at all, or it's been loosened, and that way you can know you need to reapply it. There's a lot of ways you can make sure that certain bolts are tight, but just going around and making sure whatever the mechanisms you're responsible for, if you're one of the pit members, that all of that is tight and ready to go. Snap rings are in place, shaft collars are secured. Any sort of fastener on the robot isn't coming loose. Looking at rivets and seeing if they're starting to pry up or get loose in any way, if something's rattling or if things start making weird noises. All of those are signs that something on the robot needs to be fixed. It's not quite right. And if we can catch it early when we see a loose bolt, it means hopefully like an entire mechanism won't fall off on the field, or we won't have a failure in an actual match. This is why we need to be constantly monitoring the robot and trying to just upkeep it whenever possible, because we want to avoid those big failures on the actual field. Bumper numbers and bumper damage happens a lot. The bumpers are the part of the robot that interact with the field and with the other robots the most, right? That's their job. They have to run into stuff. And because of that, they take quite a bit of damage. So you're going to see depending on how you build your bumpers, our bumpers, we have like stick-on numbers, and parts of them will start curling up or peel off or get ripped off. So we'll make sure we have like different sale repair tape and things to fix some of the numbers if we need to. We'll have replacement numbers if we have to replace a whole number side or anything. And then we also have bumper repair tape specifically for any rips and cuts in the actual fabric itself, so that we don't have it become a big issue and we have to like replace the entire bumpers mid-season or at an event and we're just like covering in gaff tape. So we have actual sale repair tape that's designed for the fabric that we use. So we're ready to fix the bumpers when they have issues, because we know they're going to have issues. Almost every bumpers throughout the seasons have some sort of issues, just because we're constantly running them into things. And then the other place is the mounting hardware itself is really important. That also takes a lot of the impact. especially if even if you're accidentally, like if you're not designed to, but if you start lifting the robot up and down by the bumpers, or even on the field, if it comes down on something that's taking a lot of weight of the robot, that mounting hardware might start to bend, might start to get loose. It's definitely important to make sure that everything is staying tight and that you have that same fit of your bumpers that you designed for when you first made them. Otherwise, we can start replacing things or figure out a solution to make them a little bit better. Electrical maintenance. So this one is also very important because it's very easy to overlook something in the electrical system. We can build it and design it, but before our first event, everything's great. Every single connection is zip tied and secured and awesome. And then as things happen throughout the event or throughout the season, something will get unplugged because we were testing something or something failed and we were swapping it and we did it really fast. And it might work for a match, but then if we don't go back and fix it properly, we'll eventually have a different failure on the actual field. So if we don't have a zip tie across one of our connections and that one comes undone, maybe we don't climb a match because a motor is unplugged or a CAN bus got disconnected or something like that. So we want to be very diligent about our connections and that everything is secured, zip tied, some things get taped, whatever it is to where it's not easy for anything to come unplugged unless we intentionally want it to unplugged, right? Like almost every electrical connection we do, we want to have to like use a tool to unplug it if at all possible. The other big place that are very important in the electrical system and doesn't get checked as often as it should on teams is all of your main power connections. So from the connections at the battery themselves, so the actual terminals where we bolt the wires to the battery, those need to be very tight. If those start getting loose, you can get intermittent connections, you can add resistance to that circuit and just cause your robot to not have as much energy as it should from that battery. Same going with the connectors at the ends of the battery cables. If those crimps aren't good or if those aren't seated properly, you can start having problems. Same with the connection on the robot. And then all of that main 6 gauge, 4 gauge, the big wire, like the battery wire, all of that going through to the main breaker and to the power distribution panel or hub, and those connections there as well. So if all of those are secure, your robot's going to be okay. But if any one of those are loose along that path, that's one of the easiest ways for your robot to start messing up. Because you just will have intermittent power issues. You might get radio or robo-RIA resets. You might get all of these weird kind of things happening with your electrical system and you're not sure why. And it just came down to a few loose cables between your battery and your actual power distribution panel somewhere. So those are really important to be checking constantly. Make sure nothing is loose. Those are really tight. We'll swap the nuts on the main breaker to be lock nuts so they don't vibrate loose because they come with like Kep's nuts, which have the little thing on there. They're supposed to make them not loose, but they still get loose over time. So if you put actual quarter 28 lock nuts on there, it secures them and makes it so that it can't vibrate loose. The new power distribution hub from Rev should make that connection at the panels toolless now, so those connectors should be good. Hopefully when we get those in our hand, we'll be able to see those. But otherwise, we'd have to open that cover and check the, I believe, M6 bolts on the CTRE panel and make sure those are tight for any of the old ones. But just that path is very important. And then anywhere else where you have power connections on your subsystems, making sure those are connected, zip tied, secured, out of the way, like make sure none of the wires are in the way of any moving mechanisms. You don't want your like intake coming down and it rips a wire open and makes a connection fail, unplugs a motor, something like that. Making sure they're all nice and neat and the wires and connections are where they're supposed to be on the robot. Okay, so that's the pretty simple version of maintenance. There's definitely more stuff to talk about, especially on robot specific things. Triage is something I hadn't seen done in a presentation very often, and our students actually requested it after we were at the Texas Cup this summer. So we're going to talk about how we do kind of emergency repairs to the robot. What happens when something's broken, you don't have time to actually replace it and fix it or fully repair it, and you just have to get something to fix it and get it at least ready to be put on the field and make it a little bit better than the state it's in. Triage is kind of weird. It's the term triage is normally used when you're talking like in a medical situation, right? Someone's injured in the field and you just need to get them patched up to be able to get them to the hospital to fully get them healthy. So for the robot, our goal is just to get the robot ready for a match that's coming up very, very soon and get the best solution we can with whatever time and resources we have available. We're very much just mitigating a problem. We are not repairing it. Ideally, we'll figure out a time in the schedule of the event where you can fully repair it if possible. If it happens in a qualification match, if it happens in elims, it may just be repairing, or playoffs, it may just be repairing it between every match and trying to just make it incrementally better until you either win or you're eliminated. This is normally when you don't have the time. Sometimes it's when you don't have the supplies to fully fix whatever broke, right? If you didn't have a spare of something, if something broke that you didn't think was going to, ideally you should have spares of almost everything you can, or at least be able to get it from somebody else at the event sometimes. And we can't fully design and implement a repair at the venue. We just need something to work right now in the emergency. What do we have on hand? We don't have a lot of time. Let's go get it fixed. So one of the first things to talk about is what that kind of process looks like in the pit itself. And so we'll normally be either coming back from an event or a match, or maybe we didn't notice when we were coming back and someone in like a system check or something in the pit notices that something fails. The procedure here is to first identify the problem. So this is where either it happens in the match, we saw something happen, maybe like something broke and we saw the intake mess up, or something else happen mid-match and we start looking at it literally as we're pulling the robot off the field and putting it on the cart. Drive team will normally start talking about it. We'll get it back to the pit with the rest of the pit crew and we'll figure out kind of what's going on. Sometimes it happens in pit with the system checks where something fails, somebody notices, they're just looking around, they notice something's broken, something's not right, and we have to figure out what that problem is. Once we identify the problem, the biggest step and a really important step that doesn't happen sometimes and it ends up causing a lot more issues is somebody will try to solve it without telling the whole team what the problem is or telling the pit crew what the problem is. So it's very important to tell the mechanism leads, so whoever's in charge of that mechanism, sometimes that'll get kind of transferred based on how pit's going and things, so somebody will be more responsible for it at an event than they were for like the design of it. But somebody has an idea of kind of who's responsible for that mechanism at the event. And then also for Spectrum, telling me, whoever the mentor is in charge of the team, whoever the pit boss is, whatever you want to call it, it's just really important to keep that communication channel open so that we have multiple ideas for how to fix it. Because the fix or repair is, somebody might be in a rush or a panic and go, oh, this is the best way to do it, and they start drilling or cutting or whatever they're going to try to do to fix it. And in reality, maybe we have more time, or we have a different resource or different solutions that they don't know about. So their fix may be causing more harm than good. So once we've kind of told enough people and everyone is thinking of the problem, we can start discussing it. But the first thing we have to do is figure out, when do we need it fixed? So this is when we look at the match schedule, we figure out what time it is now, kind of where the field is, are they delayed, how many more matches until it's our turn. In the playoffs, sometimes this is, do we have a timeout? So are we going to have 6 minutes to fix this, 12 minutes to fix this, 20 minutes to fix this, whatever time allotment it is. And at that point, we kind of start getting a timer going. In the past, we haven't made a actual timer. Sometimes we'll assign someone in the pit to be the timer, be like, hey, start giving us time checks every, give us a 5-minute countdown, whatever, start telling us time before we have to walk out to the pit or to the field. At some point there was a discussion about figuring out how to like get an actual clock we could set a timer on so everyone could look up and see it, or set it up on a laptop or something. Because that time in these moments is by far the most important thing. That's the thing we're limited on. We have to get to the field within a reasonable amount of time. Like, there's things we can do to push it a little bit, and make the match start a little bit later and stuff, and we'll do whatever we can. And like, the volunteers are very nice and forgiving most of the time, depending on what we're doing, that they understand if we have a second or two that we need to do. If we need 30 more seconds, you can normally get it. but you definitely need to be working your way to the field pretty quickly when it's your time to compete. So once we kind of have that, we now have how much time we have. Everyone's aware of the problem. We can start suggesting solutions. So now we're talking it through. What do we need to do to get the best possible outcome with the amount of time and resources we have? Sometimes it's a negotiation of, what's the approximate time do we think to actually replace it? Like if the intake is broke somehow and we have a spare intake, how long does we think it takes to replace it in the current state with the tools we have? Maybe we're field side because it's in the middle of the playoffs. Maybe we're in our pit. So there's a lot of different things that can go on. And ideally, we're designing things to be replaced very quickly. Some of that is how we design mechanisms. We want to be able to swap them in and out if we can. But it doesn't always work that way. There's some things where you just can't fix. You don't have the stuff to do it. You don't have the time to do it. And so that debate kind of goes on and be like, we might be able to get it done in 8 minutes, and we'll push it, and we'll try to do the full repair. Other times is, no, we just don't have another intake. We got to patch this and make it work somehow. While that's happening, while we're kind of in that discussion, if you're not a part of the discussion, so depending on maybe it's not your mechanism, maybe you just don't have an idea of how to solve it, one of the things you can definitely be doing is start figuring out what things are going to be needed to solve the problem. And you can start predicting, okay, we know that we're going to need the certain wrenches and screwdrivers and drills, zip ties, tape, whatever it is, and we can start getting all of that stuff ready. In a lot of these situations, the robot kind of becomes the patient, and whoever's doing the main fixings becomes the surgeon, and we have people just assisting, right? Like somebody will put their hand up and be like, hey, drills, 5/32 Allen wrench, whatever, blue Allen wrench, if you're working on our color system, 3/8 wrench, whatever, and they're just asking for it, and it gets put in their hand, and they're just going, right? You have to saving as much time as possible to try to get it done as quickly as possible, because ideally our goal is to get it fully built up to where we can at least test it a little bit before we have to put it on the field. Like where ideally we're not literally tightening bolts while we're on the field or walking to the field. Sometimes that's the only way. We've done that numerous times. We'll talk about that in a little bit. But preferably, we're trying to get as much time and get this done as quick as possible so we can try to get it fixed. And then at that point, once we've kind of talked about the solutions, we're going to choose one and we're going to implement it as quickly as we can as that team, right? We're going to try to do it as quickly to get it done to whatever solution we've decided is the best. There are a lot of different things that can break in these ways. We're going to go over a couple of them, and then I have some examples of how some teams are able to do some of these triage type fixes. Zip ties is one of the most important things in triage. At events in general, I'll normally have a few zip ties just on me in my pockets. So if I'm on the field and something happens to our robot or to our partner robot, a lot of times the simplest thing to do is just zip tie something up, especially when it's like a frame perimeter issue. Something got bent, somebody didn't notice. We're sticking at a frame and we're setting the robot on the field, and we're not going to be legal, and they're going to disable us to start the match. It's a lot nicer just to be able to zip tie and play defense if you have to, if you can't use your intake, whatever. Having that thing ready just to reattach, zip tie, connect, hold a battery together, whatever it is, zip ties can help fix it really, really fast. They're rarely the right fix, right? This is triage, this isn't repair. But if we're in queue, if we're on the field, zip ties have saved us countless times. We've had like bolts missing on like a pneumatic actuation or something where it was normally like the bolt was acting as the pin or axle, and we've just zip tied through it, and the pneumatic was able to go up and down a few times in the match to make it work. Like ideally we don't have those situations now, right? Ideally we try to get as much of that solved in system checks and repaired properly in the pit, but it doesn't always happen, especially as we get into like off seasons and stuff. We get a little bit more lax with our procedures. We have different people doing things. A lot of times these are the times where these triage things need to happen the most, just because we're not doing all of the preventative maintenance that we should be doing, and the robots also just get older and a little bit more dinged up as they play more and more matches. Sometimes it's important just to put a lot of them. Like if you're replacing a bolt with zip ties, there's no reason just to put one. Just zip tie 10 of them there, and that'll make it a little bit harder for it to break, right? They'll be a little bit stronger, just there's more material there if it needs to be. So having a few different sizes, we always keep them on the cart in our toolbox there, because they solve a lot of issues very quickly. VHB tape. So VHB is a double stick tape made by 3M. They are it's donated into the kit of parts a lot. It's also in first choice, so almost every FRC team accumulates a lot of it. We get a pretty big roll every year, sometimes multiple. And it is incredibly strong stuff. If you clean both sides, or clean both materials that you're sticking together, and you put a lot of pressure on it, it holds very, very hard. Like, it is very difficult to get off unless you are prying it off. So there are a ton of times where you don't have a time enough to actually drill and rivet something, or you just don't have stuff on you, and you just need two flat things to be stuck together for a match. VHB can do that. You can take a lot of it, apply it very liberally, shove it together, and it'll probably hold depending on what the situation is. There's a lot of times where it has definitely saved us throughout the years of my FRC career, and just getting stuff mounted when we didn't have time to do the right tool. If we just needed to get a speed controller back in place or something because the bolts came out, or zip ties or something, just stick it back to the belly pan. Whatever it is that's messing up, just sticking VHB to something, shoving it back into the robot, and putting it on the field is often the best way to get it solved, in queue especially. So a lot of times these are ones that are just, we have no time, we're putting the robot on the field. Zip ties and VHB can help with that a lot. When we do have a little bit more time, so we're back in the pit normally, we have drills and tools and material around. A lot of times when we're having cracked plates, so plastic is great for a lot of things. We use Lexan all over our robot, and in normal situations it holds up very well. But sometimes we don't get either the design quite right, or it gets put in a situation where we didn't expect it, so it gets too much force, or the loads get really weird to where they're going to bend or crack in kind of weird ways. There's sometimes just fatigue, like the robot's just done the same thing over and over again and hit stuff a lot more than we thought, and we end up breaking something. So this is a photo from Triple Helix 2363 of them adding in these gussets to a polycarbonate plate that had been cracked. So they just drill through the gussets, put in rivets, and the bolt through there too. So they're just making these a lot stronger than they were when this bolt was just mounted into the polycarbonate. It was causing problems, or was cracking around this bolt, I think. So drilling and riveting gussets is a big help. I think we did this in Texas Cup to our 3847 robot. Part of our intake got cracked and messed up, so we put a gusset across it, drilled and rivet, solved the problem. It was a lot easier to do that than trying to replace the entire intake plates, or we might have already done that and we didn't have any more intake plates left. I don't really remember, but things like that where you just have some piece that's cracked, ripping, the bolt's not staying in anymore, you can replace that specific bolt hole with the gusset and rivet it on in place to get you through the event. Tape can be used around the gusset if you need to. If this is a structural piece or something, you can put the gusset on and just tape it on if you can't actually rivet it. We'll see a splint be used with zip ties, or kind of putting a bolt or anything stiff. I think one of the examples actually uses a wrench here in a little bit. Anything kind of stiff to the plate where you can get it secured, tape, zip ties, whatever. Same way you splint your finger to not let it bend. Our goal here is just to not let that piece of plastic bend at that break point anymore. So we're going to take something stiff and rigid, get it secured up to the side of it, tape, zip ties, whatever, and kind of hold it together for as long as we can, at least. 4337 brackets. So this little part, I don't know who first found it and brought it into FRC. Adam Hurd and 973 have a whole video on them on YouTube. They are awesome. You can use them all over in robot designs. They are also very, very useful in robot repairs. We called them right angle rivets for a while because sometimes you just need to rivet something and it's not next to it, it's just at 90 degrees. So you pop 2 rivets in and it solves the problem. They're really, really cheap. I think they cost like 10, 15 cents. So I think we buy them in like the thousands. I don't even know. We have giant bags of them. And we can very quickly drill a couple holes, put 2 rivets through, and get something secured at perpendicular to something else, where tape or something just doesn't quite work right. Zip ties don't quite work right. Having these around is super useful. We keep them in our T-stack toolboxes so that we always have them at whatever events we're at. We can also put zip ties through them if we don't have time to rivet. There's very helpful little brackets to get an extra little bit of mounting or rigidity wherever we need. And they're very useful to have on hand for triage stuff. Thin Lexan. So 16th inch thick or so pieces of polycarbonate or Lexan are super useful because we can cut them using aviation snips. We often call them shears on Spectrum. I don't entirely know why. And they can also be bent by hand. So a lot of times if you have like a weird shape you need to patch or something, you can take a piece of really thin Lexan, draw it with a permanent marker, cut it out, drill a few holes, bend it if you need to, and you can get something to imitate whatever part you're trying to repair really, really fast without any sort of like power tools or anything. And it's relatively strong depending on how you're using it. And it can come in really handy to patch things or make a hard stop. Or just if you need something to connect two things, having thin Lexan in hand with something that's able to cut it, draw, bend, drill, and you can kind of very quickly make whatever the part is you need to get created without too much work. Okay, this one should be used less often. I put it here because we definitely had to use it once, but ideally we're not doing it too much. If you do have a situation where you need to have you need to have something connected to a shaft, and you don't have a way to put like a shaft collar or to hold it on, or if it's not transferring torque anymore, like the hex completely rounded out, and so it's just spinning on the shaft instead of spinning with the shaft. One of the things you can do is you can drill a hole through the shaft and hub, and then you can either put a bolt through it to act as a pin. So sometimes if it's big enough, you can drill all the way through, put a bolt and a nut on the other side, and then now that bolt is kind of doing the torque transfer that the either hex was used to be doing or it was around, whatever was happening before that's no longer working, the bolt can take that place. As a very last resort, most of the time, if you have a really small thing and it's gonna like fall off and you don't have room or whatever it is, if you drill through the hub and shaft with a very small drill bit, and then you proceed to like wiggle and bend that drill bit, you can snap the drill bit in half and leave the drill bit in the hole that it just drilled, and it can act as the pin. We had to do this, and it was actually we had a roll pin, like we had it all designed at one point in our 2017 robot where we had a sprocket that had to sit right at the edge of the shaft for clearance reasons. There was a roll pin in it at one point. It broke or something happened. I don't entirely remember, but we were late. We were at the field, I think during the playoffs, and we ended up just taking a small 16th inch drill bit or so, drilling through the sprocket and shaft, snapping it off, and that sprocket stayed there, as far as I know, for like forever until we took apart that robot, because there's no easy way to get it off anymore because it was just pinned into a blind hole. But it held on and did its job. But ideally, you don't have to do that very often. It was not a great design. It could have been designed better to be repaired than what it was. But if it needs to be done, it needs to be done to try to get it working. So this is one. Tape as a shaft collar is something that actually comes over from prototyping. I should find a picture for this for the presentation. But basically, you can just wrap electrical tape or gaff tape or whatever tape you want on two sides of a piece of hex shaft where a wheel or sprocket or anything is, and then the because the hex on the actual wheel or sprocket isn't big enough to go around the tape, it will largely just stay in place. If whatever it has a lot of side load where it's trying to pull that wheel or sprocket sideways, it might start bunching up or moving the tape. So you might need to put a lot of layers, anything to kind of hold it in place until you can actually get a shaft collar or something else actually wrapped around it that's going to secure it for real, or spacers or whatever's supposed to be there. But in a pinch, running tape around it works. Sometimes you can make quick spacers that you can actually snap on. So if it's just like 1/2 inch hex shaft, you can take a piece of like 1/2 inch PVC and cut a section out of the side of it, make it the right length, cut a section out of the side of it, and like get it to snap over the hex shaft, and that can kind of act as a spacer for a little bit if somehow you lost a spacer or something didn't fit right. So there's other ways to kind of do this same thing quickly, but really you're just trying to make sure whatever is supposed to not move side to side doesn't for that match, until you can get a real fix. Electrical repairs. So similar to electrical maintenance, sometimes the electrical system is just going to fail and you don't have enough time to do the real fix. If you get like wires that are just cut, wrapping them in electrical tape, that's what electrical tape is for, or a large part of it. So if it just ends up getting a slice through it and you have exposed wire on the inside, wrapping electrical tape is fine. And that sometimes is the permanent fix, unless we really need to, for some reason, replace the whole wire, depending on how it's cut. If it's fully broken, or if the crimp is hard to get to, like you can't replace it somehow, it's buried in the robot. A lot of times it's a much easier, instead of replacing the end of the wire that got messed up and trying to re-crimp it somehow, a lot of times it's much easier just to replace the entire wire and leave the bad one there. You just disconnect the two ends from wherever they are, make a new wire that goes in a different path, to where you can work on it outside of the robot and put it in. Leaving that disconnected wire normally is going to be fine, as long as you're not like exactly at the weight limit. And you can solve the problem faster by making an entirely new wire than you can by trying to repair the one that's broken, buried inside your robot somewhere that's really hard to get to. There's definitely a case where, yeah, the right way might work, but it just doesn't, because of the situation and how much obstacles and everything else there is to try to get the tooling down into the belly of the robot. The same goes for motor controllers. A lot of teams will try to build custom ways to make quick swappable motor controllers around. One, you shouldn't have motor controllers failing that often, right? It shouldn't be a thing we're expecting to happen. We should be trying to get our electrical system fully wired and mounted and clean to where they're going to last the full season. But if something does happen and we need to swap something, most of the time it's going to be easier just to strap in a new motor controller than it is to even remove the old one. So a lot of times we'll just disconnect it with the Andersons, wherever the quick disconnects are, plug in the new one, either VHB or zip tie it down if we have to, configure it, whatever we need to do to get it to the right settings, or get it plugged into the right place, whatever it is. But we don't really need to remove the old one most of the time, as long as we're not above the weight limit. And again, this doesn't happen very often. Most of the time you can do it. You can walk by the inspection station, tell them what happened. Sometimes they'll make you put it on the scale. Sometimes they won't. It just depends on what the inspectors want you to do. But it does get you working properly without having to like unbolt whatever the motor controller is or figure out how to remove it when you just don't need to. That's not, the goal isn't to take out the bad thing. The goal is just to get the robot working again. So this one isn't really necessarily triage as much as it is just making robots work better sometimes. So a lot of times we'll have either a partner robot who's not driving well, maybe they're too light and they're too like front or rear heavy, they're tipping over, some sort of problem like that. Maybe it's your own robot. We've had issues where maybe we like removed a whole mechanism because something wasn't working at all, but now our weight balance was really far off, so we need to be able to put weight somehow into the robot. This gets tricky with the rules, and you can definitely do it in not good ways, and inspectors will get annoyed at you and possibly tell you you can't do it and tell your robot it's illegal. So the ways that are easiest is to get heavy objects that aren't going to mess up the field at all if they open or get damaged. Because teams will try to put like buckets of nuts or bolts or things on the robot, and that's just not good, because if something happens and they open up and you have a whole bunch of nuts rolling around the field, it takes a long time to clean up. The whole event is delayed at that point. We don't want that. So ideally, if you're going to try to put weight on a robot, you want it to be solid objects that are heavy. And some of the solid objects that are heavy that we normally have with us in our pit are going to be either something like a vise. So if we happen to have brought a full vise, one of the bigger ones, very convenient. It has its own mounting system built in. You can clamp it directly to the robot. They can weigh up to like 8 pounds. So if you need to put a lot of weight somewhere, it works. The other option normally is going to be some of our heavier tools that we'll have, hammers, dead blows. You can get a few pounds pretty easily with that type of things from most FRC pits. You can get them strapped, zip tied, taped to a robot, and they'll get secured nicely. And then worst case, if you didn't secure it very well, it falls off. There's just a hammer on the field and not 1,000 nuts. If you have a little bit more time and we're doing this, you can actually get dumbbells or something. If there's a store around and you can get a few 5-pound weights, you can strap those to a robot too. That works. Or if you happen to have a big chunk of steel, whatever works. That ideally is solid and not lots of little things whenever possible. Okay. So the last thing we're gonna do is we'll look at 4 or 5 examples here of ways people had to fix their robots very, very quickly. So this was an example that was sent to me from team 2220, and they had a issue with their intake to where it wasn't deploying at the right height, so they couldn't intake balls. What they figured out is they just needed to stop the intake cylinder from going as low as it could, and that would get it to be good enough for the match to where they could start intaking again. The way the story was told was they had 5 minutes until the next match. So it was right. This is a triage moment, right, where they didn't have enough time to do a real fix. They had 5 minutes. They threw the hard stop, so they literally pulled this Allen wrench set out of their toolbox, gaff taped around this intake support, and that led it so that when the cylinder pushed down, it would rest against here, and it would work that match. It ended up bending the cylinder, so it bent both cylinders. The other one was already bent, which was the problem, but they didn't have time to replace that cylinder. So during the match, they ended up basically sacrificing the good one, but it allowed them to keep working and allowed that match to go and be successful. And then they had enough time after that match to swap both, so it was fine, right? So they were actually literally kind of not intentionally damaging their robot, but doing a fix that ended up causing a problem. They didn't necessarily know it was going to cause the problem. But it bought them time to where they could fix it again properly after that match. Here's the wrench splint I was discussing earlier. So team 930, they had a broken piece of polycarb, and they didn't have an easy way to fix it. So they literally took a wrench out of their toolbox and a lot of zip ties and made it get attached to all of the holes and just got it enough stiffness and support to where it could run for a little while until they could either make a real fix or the event ended, one of the two. I'm not entirely sure how this ended, but this is definitely something where it's a triage moment where like we just need something the right size that we can get in there attached in some way and just keep these two things together. Gusset Fix. So this was Hype 5254. Something happened. The bearing hole messed up on one of these gussets, or they didn't have one, or something like that happened. So they ended up just they jerry-rigged 2 gussets together to get the right hole for their elevator. I think this is 2015. We have the totes back here. And so this got them the solution, and they ran this through all of IRI, I believe. And so this is definitely a little bit less triage, they had a little bit more time to figure it out. This was just a part they didn't have, and so they had to fix it the day before. But it's still limited time, right? The real solution was to order a new part. They didn't have that time to do it, so they had to figure out a way to make something work for the event. There's another way where tools come into play. This was an intake being held together by a clamp, so I think I pulled this one off of a chief post by CMote. And so some part of this motor was trying to be twisted back in, right? So it was trying to get pulled, or maybe this side was getting pulled. And so they just weren't keeping these chain spacing correct, so then their intake wouldn't work. So they turned the clamp into a spreader. So a lot of clamps will have this feature where you can like turn them around and you can use it to push things apart instead of pull things together. They got it spread to the distance they wanted, so you can pull this handle and like put pressure on it and it'll open this thing up. And they just taped it around this bar so that the clamp wouldn't fall off, and that kept the chain the right distance away, allowed them to keep tension in this chain, and get their intake working for at least a little while longer. This one's a little bit trickier to see. So this is from 1745 up in Dallas, and they were having issues with the winch solution on their elevator and kind of like this ratchet strap getting caught on things. And so they literally ended up taking a part of the game piece. So the 2018 game piece was the milk crates. So this white section here that's bolted to their robot was cut out from a milk crate to be able to act as a strap guide to get the winch strap into place and not get it caught where it shouldn't have been. So they literally had to just use the game piece for that year to solve a problem on their robot. Okay, so I think that's all we have. But yeah, so a lot of the time, just kind of summarizing, it's literally just trying to figure out what resources you have, how much time you have, and what you can do to make the problem less severe. Some other examples of things we've done very quickly, a lot of times like in Q, or just like playoff changes to things in the off seasons, we've taped and strapped different things to robots. I think we had like a broomstick strapped to our 2015 robot to act as like a can grabber in one of our off-season events. We've taken an entire roll of gaff tape and taped it around a team's power switch, their main breaker, because their robot was getting turned off by balls when a ball like landed on it. So we took an entire roll of gaff tape that happened to be like the right diameter, put it around it and taped it down, so then you had to like reach your hand inside the roll to turn it off, and the ball couldn't do it. So whatever it is just identifying that problem, figuring out a way to help make it less bad until we can make a more permanent fix when we have more time.